everybody, I'm Matt Ike. We're here to talk about various lumber sizes and some of the terminology that we use around to describe various sizes of dimensional lumber. So let's just start off real fast, jump right in. First thing I have is what's commonly known as a 2x6. And the first thing we're going to talk about is the fact that that's what we call it. So it's its name or its nominal dimension size. So in this case we call this a 2x6, but it's actually not 2 inches by 6 inches in actuality. So what we like to call that is its actual dimension. So if we put a tape measure on it, we're going to see 5.5 inches instead of 6, and we're going to see 1.5 inches instead of 2 inches. The reason for that is when lumber is processed at a mill, they'll cut it very close to the named or nominal dimension, and then they do a process called surfacing, and we often will call that S4S. You'll see that term sometimes. Just get it up here. And what that means is surfaced for sides. Okay, so what they do is they run it through a planer. It makes the lumber smooth, smoother than it would be if it's just rough sawn. All right, so it's important to understand that. If we come to another common size, here we have a 2x4, probably the most well-known piece of lumber in North America. Instead of 4 inches, it's 3.5. And its thickness remains the same at 1.5. So 1.5 actual, 2 inches nominal or its name, 4 inches wide being its name, 3.5 being its actual. Now for the astute viewers, anyone focusing in will notice it's not exactly 3.5. Lumber is very prone to expanding and shrinking depending on its relative humidity, all sorts of things, but a little bit out of our scope here, but it is a hygroscopic wood, so it has the ability to absorb moisture and lose moisture depending on the ambient environment. So just some common sizes here. We just have a small chart here to take into consideration some common sizes. So we have 1x4. Again, this is our column with our name or our nominal dimension size, so we refer to it as a 1x4, a 2x4, a 2x6, 2x8, there's 2x10, there's 2x12 and such. The first three follow a pretty good sort of a half-inch deduction, we might want to call it. It's fairly standard. A 1x4 is, so rather than being an inch thick, it's 3/4 of an inch thick. And instead of being 4 inches wide, it's 3.5 inches wide. If we want to use metric, we can apply 19 millimeters for 3/4, 3.5 inches, 89 millimeters wide. 2x4 is super common. It's a 1.5 by 3.5, okay? Or 38 by 89. 2x6, super common in construction, 1.5 by 5.5, or 38 by 140. As we get into some of the larger nominal dimension sizes, 2x8, 2x10, you'll notice that the half-inch difference, 6 to 5.5, 4 to 3.5, and again, you'll notice something a little bit odd happens here. It's an industry standard. Our 8 inches, we actually lose 3/4 of an inch. Our thickness remains the same, our thickness, but our width changes. We're taking, in the surfacing process, the planing process, if you will, they're removing a little bit more material. And that continues on to items like 2x10. We would have an 1.5 inches by 9 1/4. And then after that, we do, I think, a 38 by 285. Yeah, so in summary, the important thing to remember that it's named one thing and its actual size is another. So once we know that terminology and we put those things on, we can apply them to either our construction practices or our plan reading and go from there. Just to continue on a little bit with the explanation about different lumber sizes is we just want to explain a little bit about imperial and metric measurement. So we've provided the metric over here just for some familiarity. So pretty much 100% of the time in residential construction in North America, Canada and the US, we're going to be dealing with imperial measurement, so feet and inches. Not familiar for everybody, so we'd like to provide this equivalency over here. We aren't going to see too many plans in residential construction that are going to be dimensioned in metric. It happens a fair bit, but this is the staple. But we like to put it on here for relevancy so everybody can be a little bit more comfortable with these sizes. So now we're looking at a little bit of a mock-up of a small building. And what we want to accomplish now is just to describe a little bit about how we read some dimensioning on the plan. Now that the house is framed, it's quite easy to explain. So let's just say, for instance, that I've got an exterior wall. This is built out of 2x4s, which we know is not a 2x4. Actually, it's 1.5 inches by 3.5 inches. And I've got some exterior sheathing. So on our plans, we don't want to talk about siding, we don't want to talk about brick, we don't want to talk about exterior finishes, because the plans only represent the structure of the house. In this case, our wooden components, which is our vertical studs and our exterior sheathing, okay? So quite often on our plans, the dimension from the outside to make something on the inside relative, we'll measure from the outside of the building. I can't get my tape through the wall. So here's what the framer would do, or how we can interpret it. So if we come down to the floor, and let's just say we've got a plan that tells the framer that we want to put something at 4 feet from outside to the inside of the 2.5 or 3.5 inch wide partition wall. So here's what we need to do. What the framer will do is they'll put their tape to the inside of the bottom plate of the wall. So the inside of the 3.5 and the exterior sheathing. And if the plan tells us that we want to come to 4 feet, we'll come to 4 feet, and what we're going to do on our tape is subtract the thickness of the wall. So in our case, we can quickly call it 4 inches. Assuming that the outside sheathing is at 1/2 inch thick. The 2x4, as we know, is 3.5 inches thick. 3.5 plus 1/2 is 4 inches. So all we need to do is we can come back 4 feet, or 48 inches. Easy math, back to 44 inches. We can place our mark on the floor. Okay? So it's the same thing if I put my tape at 4 feet, and we can see how the tape is kind of curved and bent and all that kind of stuff. Because theoretically, if I could poke a hole through there, it would be hooked on the outside of the sheathing. All right, so just a little bit further explanation about the thickness of that exterior wall when we're trying to dimension from the outside of the building to the inside to find a partition wall or some sort of feature in the house. Here we've got a window opening. It's a good place to demonstrate it. We've got our 3.5 inch wide 2x4, and our sheathing, it actually is 3/8 of an inch in this case. We said 1/2 inch just to make the math easy. But if we put our tape measure on here, we can see it is actually 3 7/8, so it's 1/8 of an inch shorter. So there's a really unique way to deal with that as well when we're doing our interior measurement, trying to find that. When we get to the tape, as the previous example, and we're at that 4 foot mark, or 48 inches, we can come back to 44 quite quickly with our easy math. All we have to do to account for that missing 1/8 of an inch, because it's 3/8 sheathing, is add back the 1/8. So I'd put my mark on the floor at 44 1/8 of an inch, and I'd be bang on accurate that way.